All right, so we're going to take a look today at solving an equation with a variable on both sides. Since the variable's on both sides, we're going to have to eliminate one of them, and it doesn't matter which one, but we have to eliminate one of them using its opposite. So when we solve equations, we always start by indicating our sides, and that it's not a mathematically necessary piece of the process, but I've found that it helps for us to see where the left side is, where the right side is, so that we actually perform the operation on both sides. So our goal is to get the variable alone. That's what it means to solve. Get the equation so that it says variable equals something. So we'll go ahead and get one of these variables gone. And we just use the opposite. It doesn't matter which one. I'm going to choose this one because there's already more stuff with it. This variable's already sort of alone over here. So we'll go ahead and eliminate this negative x. And as I said, we will eliminate the negative x using its opposite. The opposite of a negative x is a positive x, and we'll use that positive x on both sides. From there, we can combine our like terms, and we'll bring down an equivalent equation. So we have a negative x and a positive x. Those are like terms because they both have an x. So that's 0. Opposites cancel out. So we have 0 plus 2. The equal sign will come down. And then we have x plus x, which is 2x. Remember, there's that invisible 1 in front of each of those. So that's 2x. So we have the variable just on one side. The variable is only on the right side at this time. So we can use inverse operations to get the variable alone, or basically just have the coefficient with 1, as this one did before. So we're going to go ahead and divide by 2. When you're multiplying by 2, to undo that, you divide by 2. And you have to do that on both sides. Notice that when we divide, we use this fraction bar instead of that dot line dot that we learned in elementary school. So then we can simplify. 2x divided by 2. We don't need like terms here because it's division. But 2 divided by 2 is a 1. So I have 1 times x, and that's just going to be x. Because 1 times anything is itself. The equal sign will come down, and 2 divided by 2 is also 1. So this allows me to find that the value of x should be 1, but I always want to do a check. We're always going to check our work. So we have the opposite of x plus 2 is equal to x. Now I said x, but notice that I filled in the value of x that we found. This is how we check. We fill in x and then we simplify. So the opposite of 1 is negative 1. Negative 1 plus 2. Well, since they're opposites, we'll find the difference. And that's going to give us 1. And the value of 1 is 1. So 1 equals 1. That is a true statement. So our answer is correct. Now we'll take a look at this equation. This equation is a little more involved. It has more variables. There's 1, 2, 3, 4 terms altogether that have the variable in it. But again, we'll always start by indicating our sides, the left side and the right side, and we find that by identifying the equal sign. If there is no equal sign, there aren't sides. And if you see that there are multiple variables, multiple of the same variable, on the same side, you can combine those like terms first. So we have a negative 8x and a positive 6x. So I know that I'm going to have x because they both have x in it. And a negative 8 and a positive 6 make a negative 2. So I have a negative 2x on that side. My equal sign will come down, going to create equivalent equations. And then on the other side, I have a negative 2x, a positive x, and a negative 6. Now the negative 6 doesn't have any like terms. It is the only constant, so I'm going to write that just as it was. But I'm going to combine my like terms. These both have x, so I know they are like terms. I'll keep the x. That part has to stay. And I have a negative 2, and this invisible 1. We don't have to write it because 1 times anything is itself, so it's 1 times x. So we have a negative 2 plus a 1. which is going to give us a negative 1 or a negative x, because it's negative 1 times x. And you can write the 1 or not, but the negative especially has to be there. So I still have a variable on both sides, but now it is simplified. So I only have one variable on each side, one variable term. The process is still the same. I want to eliminate one of them so that I can get the variable alone on one side. And again, it does not matter which one you do. I tend to get rid of the one that has something else with it. It helps save me some steps. And we'll look at what happens if you don't do that in a little bit. So because this one has stuff with it, I'm going to get rid of the negative 1x. And to get rid of it, again, you just use its opposite. The opposite of a negative 1x is a positive 1x. So I'll add a positive 1x here and a positive 1x here. So these are like terms. I can combine those, but a negative 1x and a positive 1x, that's a zero pair. They will cancel out. So I have 0 minus 6, and that is negative 6. Don't forget that sign. That is one of the most common errors that I see, is that you forget your sign, and that does change the final value. Over here we have a negative 2x plus 1x. Since these are like terms, they both have that x. I know I'm going to have an x, and I have a negative 2 plus 1. That is a negative 1. Negative 1x equals negative 6. Now I know before I said that my goal is to get 1x. I don't have that yet. I have a negative 1x. So I need to get rid of that negative 1. Now the operation there, it says negative 1 times x. I know we don't usually say that, but that's what that means. It's negative 1 times x. And to undo multiplication, we will divide. So we'll divide always by the coefficient, that number with the x. So negative 1 divided by negative 1, that's 1. Anything divided by itself is 1, leaving us simply with x. I have a negative divided by a negative, that's a positive, and 6 divided by 1 is 6. So x equals 6. And again, we can plug that back in and check it. We should always check. When you check, go back to the original problem with all of these terms in it. So I have negative 8 times x plus 6 times x equals negative 2. Falling off the page here. Times x plus 1 times x minus 6. So then I fill these in. X was 6, so I'm going to put 6's in all of those spots. And I have negative 8 times 6, which is a negative 48. I have 6 times 6, which is 36. I have negative 2 times 6, which is negative 12. 1 times 6 is a positive 6, and then the negative 6 comes down. Now I can see right here this positive 6 and this negative 6, that's going to be 0. So I have a negative 12 on my right side. A negative 48 and a positive 36, since they are different signs, we will find the difference. So this becomes 48 minus 36. Yes, I'm allowed to do those out of order because I know that I'm going to find the difference. It's going to be negative because 48 has more pieces than 36 does, so it's going to be a negative, whatever I get. 8 minus 6 is 2, 4 minus 3 is 1, so the difference is 12, and it was negative because the 48 was bigger. And look, we have negative 12 equals negative 12. That is a true statement, so it does check. X does, in fact, equal 6. Let's take a look at another one here. This one has a variable on both sides and a constant on both sides. So this one is a little different here. As I look at my left and my right side, I can see, well, there's only one variable over here, only one variable over here, so I can't simplify the sides. So I'm going to go straight into solving. To solve this to begin with, I'm going to eliminate one of the variables. Now again, it does not matter which variable you get rid of. If you're more comfortable having the variable on the left side, remove a 12x with its opposite. If you don't like negative coefficients, remove the smaller coefficient. So I'm going to go ahead and do that because I don't like negative coefficients. So I'm going to get rid of a positive 3x using its opposite. The opposite of a positive 3x is a negative 3x. So I'm going to put that on both sides. I always have to do the same on both sides. And I can combine my like terms. Now my term was a positive 3x and I put a negative 3x. That's a 0 pair. So I have 0 minus 8, which is just the negative 8. The sign goes with the term. So that 8 was negative, it stays negative. I also have these like terms. I have a positive 12x, a negative 3x. I know I'm going to keep my x because it's not going to make a 0 like it did over here. So 12 minus 3, well, that would be 9. So I have 9x plus 7 because I need to bring down the other term. So now that I have my variable alone on one side, or I guess it's on one side, it's not on both sides anymore, it's not alone yet, I need to get rid of the constant. I always get rid of the constant next, as long as it's available to me. So my constant is a positive 7. I will eliminate it with its opposite. I have a positive 7. I will use a negative 7 to create a 0 pair. But if I do it here, I have to do it here as well. So there's a negative 7 over there. So I will combine my like terms. Constants are like terms. So I have a positive 7 and negative 7. That's 0. So I have 9x plus 0. And anything plus 0 is itself. So that's 9 times x. The equal sign comes down every step. Always create that equivalent equation. A negative 8 and a negative 7 makes a negative 15. Now some of you are looking at this and going, wait a minute, something's wrong. That won't divide. That's okay. It will divide. It won't divide evenly, but that's okay. It doesn't have to. The next step is division. I have a 9 times an x. I need to undo that. So to undo that, I'm going to divide by 9 on both sides. I'm going to have to divide by 9. 9 divided by 9 is 1. So that's good because I want a positive 1 times x, because positive 1 times x is simply x. So I will have x over here. And this is going to be equal to, now 15 divided by 9 is not a whole number. It just isn't. But that's okay because fractions are numbers. And look, we have a fraction right here. So I can write this as a negative 15 ninths. That's okay. Now 15 ninths will simplify, and that's even better. These are both divisible by 3, so this will be a negative 5 thirds. 15 divided by 3 is 5. 9 divided by 3 is 3. So x is a negative 5 thirds. Now be careful, several of you are very fond of your decimals. This would be a repeating decimal. If you try to plug this in as a terminating decimal, you're going to get a very close but incorrect check. But you always want to check. So that's what we're going to do next. We're going to plug that number back in. We're going to go to our original equation again. So we have 3 times x minus 8 equal to 12 times x plus 7. To have a negative 5 thirds here and a negative 5 thirds there as well. And we've learned how to do fractions before. We learned this in 5th grade or 6th grade. So we put this over 1 to make our multiplication easier. And we can see very quickly, oh, I can cross simplify. So those will simplify, they're both 1. So I have negative 5 minus 8. These will also simplify, they're both divisible by 3. So there's a 1 and that's a 4. 4 times negative 5 is a negative 20 plus 7. So I have negative 5 minus 8, or negative 5 plus negative 8. I can look at it that way too. A negative 5 plus negative 8 is going to be a negative 13. The equal sign should come down, always, always. A negative 20 and a positive 7. Well, the signs are different, so we're going to find the difference. We'll do 20 minus 7. The 20 had more pieces and it had the negative sign, so it's going to be negative. So 20 minus 7, well, I'm going to have to borrow. So there's a 3. That's 13. So negative 13 equals negative 13? Yes, it does. That's our check. So since it checks, we know that not only do we find an answer, but that it's okay that it's a fraction. That is perfectly fine. All right, here's this one. This one's long, but that's okay. We're still going to look at our left and our right sides, separated by that equal sign. And we see that there's a lot over here that can be simplified. Now, a lot of you immediately went, oh, we can use the distributive property. And yes, you absolutely can. We can't just pop those parentheses off because there's multiplication and then inside subtraction. The only thing that removes parentheses is the associative property, and it does not work with subtraction, which means this is a problem. Because even if we distribute, those parentheses won't be gone because this is subtraction. So what we're going to do instead is we are going to start by adding the opposite, and we're going to distribute that negative, because since there's addition out here, we won't need the parentheses anymore if we distribute that whole -2. So the 3n will stay because there's nothing out there to do anything with. So we have 3n. -2 times -2 is a +4, and the sign becomes the operation. A -2 times a -7n is going to be a positive, because it's negative times a negative, a positive 14n. And again, the sign becomes the operation. As long as you keep your sign with your term, you can allow the sign to be the operation. On the right side, we can also simplify. 4 times 1 is 4. 4 times a -8n is a -32n. Notice that because I kept the sign with the term, 4 times -8n, my sign, my -32n, my sign became my operation. On the left side, I can still combine these like terms. I have a positive 14n and a positive 3n. That's going to give me a 17n plus 4 is equal to 4 minus 32n. So my first step is always to get my variable on one side. I want the variable on just one side. I like to get rid of the lower variable so I don't have any negative coefficients. Since -32 is less than a positive 17, I'll get rid of my -32n. I'll do that with its opposite, positive 32n. And I'll put that on both sides, a positive 32n. And I will combine my like terms. A -32n and a positive 32n, that's a 0 pair, leaving me with 4. A 17n and a 32n, those are like terms because they both have n. 7, 8, 9, that's a 9, 1, and 3 is 4. So I have 49 n's plus 4, and my equal sign comes down. Now that my variable term is only on one side, I can remove the coefficient. So I'm going to subtract 4 on both sides. Positive 4 and a -4 is a 0 pair, so I have 49n equals. Now notice I didn't write this 0 because 49n plus 0 is just 49n. Positive 4 and a -4 makes a 0, and I have to write this one. I have to, it's the only thing over there. Now many of you see this and you go, oh, there's no answer. But you're not done yet. You have to divide. So we divide both sides by 49. 49 divided by 49 is 1. 1 times n is n. And 0 divided by anything is 0. So my answer is 0. Now I did promise I would take a look at what happens if you remove not necessarily the wrong variable, but not the one that I've already done. So in this problem, which we've already solved, we've checked it, we know that we got the right answer. We're still going to look at the left and the right sides, but since several of you are fond of keeping your variable on the left, a lot of you will immediately eliminate this positive x, and you'll do that with a -x, which is fine. That is perfectly fine, as long as you still follow all of those rules. So positive x and a -x, that does make a 0 pair. It is the only thing over here you have to write that 0. The equal sign comes down. A -x and a -x make a -2x. The positive 2 comes down. Now this is where a lot of you run into trouble. You lose one side of your equation, and you can't do that. You have to keep both sides. So I want to get my variable term alone, but I still have this other term. So my next step is to get rid of that other term. The term's a positive 2, use its opposite. So I'm going to subtract 2 on both sides. Positive 2 and negative 2 make a 0 pair, so that's gone. A 0 minus 2 is a negative 2, so I have negative 2 on the right. The equal sign comes down. And negative 2x on the left. Now this is going to look a lot like it did here. You see how this equation and that equation, they look very similar. The x's are on opposite sides and the signs are all different. And that's okay, that's going to happen. Our next step, since this is multiplication, we're going to divide, just like we did over here. We divided, but we're going to divide by a negative 2. Always divide by the coefficient. The coefficient was a negative 2. I'm going to divide by a negative 2 on both sides. Negative 2 divided by negative 2 is a positive 1, and that's good. That's what I want. I want a positive 1 with my variable because positive 1 times x is just x. The equal sign comes down. A negative divided by a negative is a positive. 2 divided by 2 is 1. And even if I get rid of this other variable first, I get the same answer to the same equation.